Is it the same question? No, of course it's different. Now, when there's 10 people in the race, it's stupid because, you know, if it was me in the race, what chance have I got of coming first, second or third? None. But let's say the 10 people, well, you didn't know any of them and they were all pretty evenly based, equally based. Ready? What can you write down without thinking? You'd probably think the P, or would you? So some people without thinking will go 10, 23. Some people will just look at it and go, I don't think that, I just know there's 10 possibilities for first, and 9 possibilities for second, and 8 possibilities for third. But the order really, really matters. Concept, order matters, order doesn't. So if the principal walks in here and he says, I want Colin, Jake and Ash. Or he walked in here and said, I want Jake, Colin and Ash. Or he walked in and said, I want whatever I was just saying. Ash, Jake and Colin. For 3 helpers. Did the order matter? No. First way of thinking, you can go 10C3. You don't even know what 10C3 is at this stage. Or do you?
I would have wrote that down, but I don't know what it means.
Yeah. So let's go back to this for a second. I'm going to talk about what this means. It actually means 10P3. Can you tell me what it means? How do you technically write it down as a rule? You put 10 with a factorial. And the bottom you can just write. But can we look at the pattern as a pattern? 10 take 3, so 10 take 3 brackets, factorial. So it's 10 factorial on 7 factorial. And of course you can go 10, 9, 8, 7, 6. Just for once, we're just going to fuss about it. And if this is any good, you can look at it another time in 6 weeks when you've completely forgotten what you're doing. How quickly do you forget maths? Stupid how much we forget. You don't know what you're going to forget, you just get forgotten. So we're left with 3 numbers starting with 10. So you can think about 3 numbers. I'm going to actually write it down. 3 numbers starting with 10. Yeah, you okay with that idea?
Yeah.
I would like a lot of you to get to that stage, but I don't know. I've had people that never get to that, never think that. They always get it right. 3 numbers starting with 10. Too easy.
3. You'd want to say descending numbers starting with 10.
No, because people automatically, when I say that, usually interpret it, but you might just make me question what I've said for a million years.
Just because some people could interpret it as 10, 11, 12.
Yeah, but I've never had anyone do that. Ever. You might be the first. Oh, you won't. Because you already know what you're doing. So how much of that did you actually need? Now, we could go to rules. I could do this without teaching you and explaining to you why. I could start with 3 numbers starting with 10 and divide it by 3, 2, 1. You know what's stupid about this? I haven't taught you why, how, or whatever. There's the pattern. Now, let's see if we can write that down in another way. Let's look at what we've got. Anyone know the pattern for it? This is not an understanding, I'm just talking about comparisons and patterns. How do I get 10C3? Has anyone learned it? I have said it, but we haven't learnt it as such. Here we go.
It's 10 factorial
Just the same as there.
over 10 minus 3 factorial
Just the same as we had there.
minus, not minus, at times 3 factorial.
Yeah. So if we did the whole thing in full, 10 factorial. Can you see this topic can go on and on? I can talk about this, like I said, easily for an hour. I don't want to. So maybe I'll make, a whole different lesson going for other details of it. Do we need to write all the ones, by the way? I'll always write them. Let's have a look what we got. The 7, 6, 5, 4, 3, 2, 1 cancels with the 7, 6, 5, and we're left with 10. I haven't shown you why it works, remember? Just showing you that this is what it is. So a lot of people, by the way, will write that first. Okay, well, let's leave it there for now. Now, you could go back to it and go the 10 people in combination. Let's go through, and my brain goes, okay, if I've taught this, I don't know how many times, 50 times? No, probably 20. And what have I said in the past and why will I look back on this later and go, why did I do it that way? What's going to come out of my head? Okay, 10 people. A, B, pretty obviously, oh, not dots, C, D, E, F, G, H, I, J, we've got 10. Permutations, pretty obvious, you can do a tree diagram, it's 10, and then it's 9, and then it's 8, you can draw up the box set and all that sort of stuff. What about this one though? It's still the same 10. If I drew up a tree diagram for that and listed them all out, I'd have A, B, C with, A, B, D with, A, B, E with, A, B, F, you're right, with A, B, G. Now what's this? I didn't know why this is going to come out my head, but it's going to. I've made up sheets about this. If I listed those 10 reasonably spaced so we don't get too mixed up, G, H, I, J, and I said, what could they do? A, B, C. Next one. A, B, D. Next one. So you could have written over here that was A, B, C, just like I've done. A, B, D, just like I've done. Next one. A, B, E. Now you could probably start the shortcut and go A, B, E, and you go, I could have written that anyway. A, B, F, what's the last one? A, B, J, and I had all the others. So how many was there? 9. So we've got 1, 2, 3, 4, 5, 6. I could do all sorts of shortcutting. It's 8, isn't it?
Oh, 8.
You know all that stuff we've been doing where it's the first 2 and another one, and if the first 2 are stuck together and all that sort of stuff? So there's 8, isn't there? So we've got 8 so far. Have I finished the A's?
No.
What else could I do?
A, C.
Instead of A with a, so this was A with a B, these are now A with a
C.
C. I could put a line across to try to keep it organised. AC with a D, AC with a E, AC with a F. Hang in there, you got your brains with me? I missed that one. AC with a G, isn't it? AC with a H. And you get all these patterns too when you start doing this one. AC with a J, and you could write them all down. How many this time? 1, 2, 3, 4, 5, 6.
You could also do A, C, B. This is true.
Okay. Can you start looking now? This is now we're talking about. Let's talk about we're just getting 3 helpers.
Oh, so this isn't the race.
Sorry, I didn't make it clear enough. If it was permutations, I'd have to go A, B, C, A, C, B, C, B, A, C, A, B, B, C, A, C. Yeah? So by the way, every group of 3 would have 6 more possibilities. Wait, so if I went from combinations to permutations. So this is about combinations, which we write as combs, and the order does not, give me a second, Josh, matter while my brain's connected and doing some of it. Okay, for every A, B, C as a perm, there are 6 ways I can write it. So what's the difference between permutations and combinations? You get whatever would have been in the permutation, and if you're grouping in 3, you divide it by 3, 2, 1. So whatever you get in permutations, ready for this? N factorial on what? Factorial. Okay.
Oh, wait,
For permutations.
Sorry, yeah.
So what would that be if we did it as combinations? It's an NPR divided by,
Be the same, but you add an extra R factorial.
you add an extra R factorial. So if we had 10, let's do it this way, for those of you not getting it, NP3, okay, let's go to this. 10C3 is 10P3 divided by what? Could say 3, 2, 1, couldn't it? So it's 10P3 divided by 3 factorial. How do you get 10 now? I'll get rid of this stuff here for a moment. How do you get 10P3 by the pattern, by the rules? 10 factorial on. Hang in there, I'm nearly done, okay. I don't know how much is going to come out of my brain. 10 take 3 factorial, am I right? Divided by 3 factorial. How do you get a fraction divided by a fraction? So if I had that as over 1, what have I got? A fraction divided by a fraction. Have you learnt invert and multiply? You leave the top one the same. 10 factorial. 10 take 3 factorial. Oops, I want to fix my writing up. What do we do with the bottom? Invert and multiply. It becomes 10 factorial. If I wrote that first on 3 factorial, 10 take, whose brain is switched off? Some of you. By the way, if this was N, C, R, follow the pattern. What's the pattern? 10 was from the top, N factorial. Where's the 3 from? The R, which is the bottom. That's R factorial. And then how do I get the 10 take 3? N take R factorial. You okay? Now I'm going to go back to here for a second and go, I could keep going through all of this process and get that. So 10 grouped in a lots of 3 where the order doesn't matter. I could keep doing this. By the way, how many answers am I going to get? This is CR, remember? So 3 into that goes 3, 2 into that goes 4, 10 by 3 is 30, by 4 is 120. So if I use this method, I'd end up with 120 combinations of 3 people. So if I had 3 more people in here and Mr. Mill said 3 volunteers, first 3 hands up. Yeah? Okay? There'd be 120 ways. You go, how can there be 120 when there's only 10 people? Well, you can go through and do it. So what do I want you to do as a result of this? None of that. I want you to just go 10, C3, 10, 9, 8 on 3, 2, 1. Whose brain thinks that way? Some people. What do the rest think? 10 factorial on 3 factorial, or 10 take 3. So probably half the planet who does this thinks that way. And then you could go, some of you will do this, 10 factorial on 3 factorial. You would think that way. I remember thinking like that at school. After a while, because we did so much of it, I wrote the other one. So question?
I was just trying to get a full understanding of it. So the
good.
the extra 3 factorial where you divide it,
Yeah.
comes from all the double ups?
All the double ups. I love it. So if we had A, B, C, D, E, order doesn't matter. And there's 3 we want. So this is permutation. The order matters. This is with order. So that'd be 5 by 4 by 3. Or you can go 5, P, 3. And then you could think about that one. A, B, C, D, E. Picking names out of a hat. Combinations, order doesn't matter. So if I picked out A, B, C, it could have been A, C, B, it could have been,
Yeah.
You probably don't need them. I'm going to say it just for a second, B, C, A, and it could have been C, A, B. And so they were, all of those were, as you call them,
Equal, or the double
they're
ups?
all the same, or they're double ups.
Yeah.
So we had the same answers here, 5 by 4 by 3,
Divided by
3 by
2
2 by 1. So if I did this down, we'll go one step further, in case it's any good.
be 6 by 5 by 4 over
Yes.
3, 2, 1.
So the permutations would be 6P4, you can go 6, 5, 4, 3, yeah?
Yeah.
Combinations would be 6C4, and you can go 6, 5, 4, 3, divided by 4, 3, 2, 1. Why? Because if I had a group of A, B, C, and D, they could have been A, B, D, C, A, C, D, B.
Yeah.
How many ways could I have done that?
4 factorial.
4 factorial, or my brain sees it as 24 automatically. When I see 4 things, I know it's 24. So you get that answer, and for each answer you got, for each group of 4, you got to divide it by. factorial, there it is there. So then you can go back to the pattern of 6 factorial on 6 take 4 factorial, or you can go 6 factorial on 4 factorial and 6 take 4 factorial. Done?
Yeah.
Okay, enough said.